My name is Julie Kring, and I'm the CEO and co-founder of Khepra. We crack carbon-carbon bonds in plastic and organic waste in order to release hydrocarbons to replace fossil fuel. By 2035, the largest corporate producers of waste have promised to be net zero. However, our recycling technology is not sufficient in order to achieve these goals. So, at IndieBio, we built a chemical reactor. In our continuous flow ultrasonic reactor, waste goes in and fuels come out. Our fuel can be sold anywhere, today, at an existing refinery, even in small amounts. We do not have to achieve economies of scale in order to commercialize this technology. Today, there's a $2 billion market for equivalent advanced fuels in comparison to the multi-trillion-dollar global market for petrochemicals. And with inline catalytic refinement, we can produce a more stable, higher quality, and diversified product, opening doors to new markets. A ton of oil is worth $273. But with sonocatalysis, we can create a product which is worth $1,000 to $1,500 per ton. This is a 4x valorization of the original product. We started with a batch reactor that used a high power, low frequency sound. And we processed multiple materials in this system. Then we moved on to a continuous flow reactor that used high intensity, focused ultrasound. Moving forward, we will build a multi-frequency system that is also continuous flow and is optimized at the benchtop scale. This information will provide us with the basis for building a minimum commercializable volume of about 500 liters. This is 1,000x the scale of our prototypes. This minimum commercializable volume will be multi-frequency, again, will be fully optimized, and will have a high feed rate in order to demonstrate the commercializability of this technology. We're using HIFU, which means that we're efficient. We have a high energy return on energy invested. For every 1 unit of energy we put in, we get 3.6 to 18 units of energy out. This is because we have a high energy transfer to the system. Our electrical to acoustic power conversion is 80 to 90%, which gives us a huge leg up on existing renewable fuels. And recirculation of the residual oil reduces the cost of solvent and creates a zero waste system. Multiple materials have produced the same results across experiments, C14 to C20 alkanes. We've tested high-density polyethylene, polypropylene, polystyrene, and mixed waste in the form of a sole of a shoe. In the future, will test low-density polyethylene, PET, and a variety of lignocellulosic wastes. Aromatics and components of JPET jet fuel have shown up in our GCMS analytics. Aromatics can be used as solvents, precursors to pharmaceuticals, and can boost the octane in existing gasoline and diesel engines, as well as the C14 aromatics can be used in jets as well as rockets. Our go-to-market is to make fuel from waste on the way to the landfill. We will take residual waste from a materials recovery facility, which we are paid a tipping fee. We will make a slurry of this waste, pass it through a series of our minimum commercializable volume reactors, fractionate the valuable products and sell those as an offtake, and recirculate the lower grade residual oil. And this can all be accomplished in the footprint a size of a brewery. By working with renewable electricity partners, we can cut our costs dramatically and share in the revenue of generating renewable electricity. We can arbitrage surplus energy during the middle of the day when there's an oversupply and use it to produce gases and fuels to generate electricity at night. Between 4 and 8 p.m., California frequently experiences rolling blackouts, and this is because of something called the duck curve. As I mentioned before, we have an oversupply of energy in the middle of the day, and we can't supply enough energy at night. We're solving this problem by reducing curtailment for our solar partners and ending negative pricing. Our business model brings together multiple streams of revenue. We're paid a tipping fee for the waste that we collect. We're paid for the energy that we provide to the grid. And we're paid for the offtake agreements that we source with refineries and chemical distributors such as BASF, Dow, and Sigma Aldrich. From a high level, Khepra is sonochemistry. We're a renewably powered platform for a plethora of applications. We're a marketplace for renewable energy and carbon offsets, which are generated with the fuel that we produce, and a solution for corporates looking to achieve net zero waste and regenerate the environment. We have a long-term IP strategy covering the process, hardware, and catalysis, with provisionals filed on the process and the hardware. I'm Julie Kring, CEO of Khepra. I have a background in biochemistry and experience leading large teams on political campaigns. My co-founder, Madeline, whom I've known for over a decade, has a background in physics and experience in engineering at Lockheed Martin and the Leibniz Institute for Materials. We're working with consultants with decades of experience in chemical engineering and energy market modeling. And our advisors include Vikas Vinayak and Rob Modeste, who collectively have decades of experience in early-stage hardware development and scale-up. In addition to that, we're working with Daria Buffito, a professor at Montreal Polytechnic, through whom we've organized a one-year research contract to model optimal reactor geometry and create lignocellulosic fuel. I welcome you to join me in solving not one, but two of the biggest global problems facing us today, our mountains of waste and our need for clean, renewable energy. Thank you.